All right, in this video, I want to explain the concept of coterminal angles. Coterminal. Co means like together or same, and terminal. So it means that they have the same terminal side when in standard position. That's what coterminal angles are. And there's this notation where you write a single squiggle. This is like a tilde, a single squiggly line to say alpha is coterminal with beta. It's not saying that these angles are equal, because generally you're talking about different angles, but they terminate in at the same ray when you put them in standard position. So let's say let's look at the example negative pi over 4. I'm going to do this example with radians. Negative pi over 4. Let's find some other angles that are coterminal with negative pi over 4. Well, one thing we could do is we could measure around the circle in a positive direction, starting from our positive x-axis here. We could go around the circle, say, like this, and then stop right there. So what angle would that be? If it stops in the same place, right, it terminates at the same side, then it's going to be coterminal. Well, that's going to be, let's see, we've got 1 pi over 4, 2 pi's over 4, 3 pi over 4's, 4 pi over 4's. This is pi over here, right? So that's 4 pi over 4. Here's 1 pi over 4, 2 pi over 4, 3 pi over 4. I'm just literally counting fourths. Here's 5 pi over 4, 6 pi over 4 is down here, and then my pi over 4 here, this is 7 pi over 4. So what I can say here is that negative pi over 4 is coterminal with 7 pi over 4. Okay, so that is an example of coterminal angles. You can wrap around the circle as many times as you want. So technically, we could do, which direction do I want to go? I want to go like, let's go around like this in the negative direction. Oh, and then go a little bit further. So if I go all the way around the circle and then keep going a little bit further, I can still like terminate in the same place. Now I drew that arrow going clockwise, so that's going to be a negative 1. So that is going to be coterminal with, that angle would be, I'm going backwards all the way around the circle. In terms of pi over 4's, that's 8 pi over 4's, and then I go one more. So that's negative 9 pi over 4. And then I could do it, let's do it one more time. Going counterclockwise around the circle, if I go all the way around and then go all the way around and then stop, right? Then it's like I went 8 pi over 4, and then an 8, 9, 10, 11, 12, 13, 14, 15. This is also coterminal with 15 pi over 4. And technically, you could keep going, right? Dot, dot, dot. You could keep going forever, and you can wrap around the circle as many times as you want, and then keep going until you get to that. As long as you always get back to that same exact terminal side, then you're going to find infinitely many different angles that are coterminal with negative pi over 4. And that's just one example. You can do this with any angle. There's always infinitely many different angles that are coterminal with any given angle. So there's a rule we can write down to express this sort of infinite number of coterminal angles. We can say t, an angle, is coterminal with another angle which you get by taking t plus a multiple of 2 pi. I'm going to write 2 pi n. So that's like taking that same angle and then adding a circle or some number of full circles, right? 2 pi is a full circle, and if you multiply it by like an integer n, this is for any n in the set of integers. Remember, z means integers, so this is an integer n. If you add an integer multiple of 2 pi, that's like adding some number of full circles to an angle. That's always going to bring you back to exactly the same place. So that's our rule for coterminal angles. Now, I want to also take this opportunity to talk about some special angles. This is not exactly related to coterminal angles, but I just thought I'd put it in the same video. I guess it's kind of related because the idea of coterminal angles means that really all we really need to worry about is angles in the first lap around the circle. Because if you measure beyond one full circle, then that's coterminal with something that's in the original circle. And for the purposes of trigonometry, we're not going to care about wrapping around the circle. So it turns out really all we need to worry about is angles within the first lap around the circle. That would be between 0 and 2 pi in radians, or between 0 degrees and 360 degrees. So let's go around this circle and label some important angles. If you have an angle like this, that could be 0 radians, which is also the same as 0 degrees. Up here, we have pi over 2 radians, which is 90 degrees. Over here, we've got pi radians, which is 180 degrees. Down here, 3 pi over 2 radians, which is 270 degrees. And then, of course, back here again, we have 2 pi radians, which is 360 degrees. And in here, we've got the pi over 4, which is the same as 45 degrees. And then we've got these two here, which are pi over 6, which is the same as 30 degrees. And this is pi over 3, which is the same as 60 degrees. And then there's other angles that we can get over here. You can do let's see, 3 pi over 4, which is the same as, 45, 90 plus another 45. That's 135 degrees. And you can do, if we do pi over 6 here, we can do that's pi over 3. If we do another third, that takes us to here. So that right there is like 2 pi over 3, 2/3 of pi. And that is your 120 degrees. And then over this pi over 6 here, if you do a 1, 2, 3, 4, 5 pi over 6, you get over here. Put that back in black again. 5 pi over 6, and that is just 30 degrees shy of 180, and that's 150 degrees. And so you can go around the circle, and I'm going to leave it to you as an exercise to go around the circle and fill in the other multiples of pi over 4 and the other multiples of pi over 6 and pi over 3. Okay, and do all of the radian and degree measurements on the bottom half of that circle. And doing this by hand is a really good exercise, going through and figuring out what all of the angles are in radians and degrees, all the multiples of pi over 3, pi over 4, pi over 6, etc., and pi over 2. That's a great exercise, but I am also going to post on D2L for you a copy of what we call the unit circle that has a bunch of information on it, and you'll have all that in a nice, pretty format for you to look at and use as a reference. Okay, but drawing it by hand is a great exercise, and figuring out what all the numbers are. Great exercise to help you familiarize yourself with this circle.